No, this is not a post bag. This is actually a small project, building a small board with 2 isolated power supplies for digital panel instruments or any digital meter. You see, there are digital meters on the market which have isolated measuring inputs, or in case of your digital handheld multimeter, it's powered by a battery. But if you have, like in my case, for the rebuild of my lab power supply, see card somewhere and link, you need, if you don't want to buy a very expensive panel module and go with the cheap Chinese ones, you need an isolated power supply, because the measurement inputs usually have a common ground with the power supply. And yeah, I'm just doing that to show you how, this is just invoice how German distributors work. So I bought 2 AC to DC converters, not Chinese converters, because they convert mains power to 5 volts through 100 milliamps, and they come in an ESD safe package, or maybe not ESD safe, but ESD dissipating. Wow, they've gone to town with the packaging, and that's all that is. Yeah, you can get these things probably cheaper from the Chinese, but let's zoom in. No focus today? Come on. Yeah. They have all the requisite testing signs, that's CE stuff. They are made in China, but they are for real export through international distributors. It's from Meanwell. It has the German TÜV, and yeah, input 277 volt AC, 60 milliamps, or 100 to 240 volt AC, 60 milliamps, 50-60 hertz, and output 5 volts, 0.2 amps. In a very neat and small package. And we will build, as I said, a little board that goes into the power supply. Yeah. So, and here we have all we need. Bit of board, 3 connectors, one for the mains input and 2 5-volt outputs, and our 2 converters. And the converters have, of course, yeah, don't try to zoom in again, or do I? They have an AC neutral input, AC live input, and of course they have a minus VC and minus VO and plus VO output. And if you think how to place these things on the board, of course the AC sides should be near together, because you want to remove all the copper there is between the AC side and the DC side. So that would be a possibility. AC to the center, but yeah, there, and output here, output there. No. Let's put them side by side. Yeah, and I leave enough space here for a 3mm hole for M3 screw, because I'm Germany, I'm metric, and okay. And one connector will fit here. That's perfect. And the other connectors will fit. Oh, we can go a row up. Then it's not completely on the board. That's not nice. That's better. It's almost flush. Okay, and the output connectors come somewhere here. By the way, these things were, I don't know, $5 or $6, including tax. And yeah, I first want to go, because I already have in a linear power supply a big transformer. I wanted to go with sorry, other way around. I wanted to go with DC-DC converters. However, if you look for DC-DC converters that have a regulated output, they are quite expensive. And when you look for ones that can in addition handle a wide input range, like you put them after your pre-regulator, where the voltage goes up and down quite a bit, then it gets even more expensive. Or if you look for ones that really can take, say, 50 volts or something, or 60 volts, like before your pre-regulator in the voltage supply, it gets really expensive. And these DC to AC types, these AC to DC types, yeah, the meanwhile you get for $5, $6. Not at DigiKey. They don't have meanwhile, I guess, but okay. Oh, let me grab a pencil here. So I need to cut here and here. Nice small board, and there's enough space in the corners for 3 screws, which should probably be plastic screws, just to be on the safe side, and we will need some isolation for the back too. But now we're going to the sawing operation, and for that to go well, I will have to change the setup, otherwise your world will be rocking. Oh, that's a microphone dangling in your view. Yeah, always secure your workpiece somehow. It makes life easier, believe me. We need that one later on. Yeah, you see how the desk is wobbling. That would be another mechanical engineering project. actually stabilizing this desk. However, I just want to go to this hole. However, my room in the cellar has currently absolutely, I hope the microphone is here somewhere. Yeah, hopefully you could understand me. My room in the cellar, where I do the other stuff, not electronics, but mechanical work, has currently no power. Hasn't had power for a month now because they are redoing the wiring in the whole building, and getting power again to my cellar is obviously not on the highest priority. So that looks better. Now we can just clean up the edges a little bit. But obviously that's not the right tool for it. Just a second. Let's see if that one works better. Oh, I must have taken the fiberglass stuff. Because it seems to be quite hard. Nevertheless, yeah. Don't want to overdo it. But I'm a fiddler for details. You might have noticed watching my videos. Almost good. Now we need 3 holes for M3 screw. Oh. No, that was just a little bit copper. 3 holes for M3 screws. Just a second. Remember when I said always secure your workpiece? I meant it. Don't try to drill things like that on the side. If you're lucky, it just won't break, but makes an ugly hole. If you're unlucky, something goes terrible wrong. Just put sacrificial board under it and go to work. Now I hope I put them into the right hole. And it's much easier that way. Oh, bad framing of the shot. Okay. By the way, Metabo. Yeah. Okay. Next comes the soldering, huh? Okay, this desk has never been seen on YouTube. So, yeah, plus is in the middle. they were just outside here in the middle. Is that the right placing? No, I think it was. Yeah. And the other one. One in. Yeah, like that. And the problem is, these are longer. That's not really a problem because we can bend the pins a little bit to hold them in. Okay, not really working. So, but I don't know. This is our primary side, and well, it's all copper and shiny, so you can't see a lot, but we will go down here and here. Yeah, now we have do we need a bridge? I mean, a jumper? That would be annoying. Yeah, but logically, this way there's actually no way how we can get this done without a jumper. Okay, I have to think about that for a second. Okay, after some consideration, I decided to do everything with isolated wire. Well, we have to cross at some point, and I don't want any wires on the front side of the board, just for visual effect. So here is live, neutral, live, neutral, and the input connector is that should be the same. It's easier to look here. It's of course will be neutral and live, pin 1 being neutral. Okay, so basically we need these 2 pins, and we need this pin and that pin and that pin and that pin. And then we remove, yeah, just to mark them in case. I go back here. Wrong mark. And then we remove all the unnecessary copper first. Because you really don't want to have that much copper on a board that has mains on it. So here together. Okay, need another tool. Okay, so it turns out scraping off the copper from a glass fiber board is actually quite a painstaking task. So I won't bore you with this, and yeah, I'll get back to you when I'm done. Okay. So I finally managed to scrape off all the unnecessary copper and leave on the main side only really the holes which I need. And while scraping it off, I decided on some small changes. First of all, I'm no longer using the stand-up connectors because all in all this would add to the height, and I wanted that small and flat as possible. The second change is, while these Molex style connectors, at least according the original Molex, are good for 250 volts AC RMS, if you take a 2-pin connector, the distance when you solder them onto the board is not good enough for 250 volts, or in my case 230 volts AC. So I decided to go on the primary side for a 3-pin connector, and we will remove that pin. Yeah, I think we first glue them the smaller connectors onto the board, but before that, yeah, let's cut off some isolation material to go onto the back side. Just a second. It's much easier to cut that stuff to size while there are no components on the board, of course. And how do I do this the best way? Yeah, this will do. Okay. And yeah, you get this out of old power supplies. For example, PC power supplies, sometimes they contain this little isolation sheets. And yeah, remember what I said about securing your work pieces, because now we also need 3 matching holes, and we use the board as a template to do that. Yeah. Should be okay. This is still a little bit too wobbly for my taste. See? That's what happens. Now we have to align the hole exactly the way it was, because I didn't secure it good enough. Yeah, as I said, shit happens. Still wobbling. Perfect. Now we have some nice isolation to go onto the back when you screw it on. So yeah, I'm a little bit you know, self-conscious, paranoid about mains voltage, but that's okay. Okay, let's glue these connectors on. You also see I filed down the edge a little bit because these edge connectors, of course, my board didn't fit exactly to the dimensions of the edge connectors, but hey, shit happens. Let's glue this in place. Yeah. Oh no. Yeah. Already there. The other two. And the last one. Okay, that's it. Close this up and yeah, now we have to start to solder. But I think I'd do something else first, which I have done beforehand, and this is remove the middle pin. Okay, just give me a second. Yeah, the right tool for the right job. Okay, it came loose. Anyway, so yeah, maybe that's for the best. Let's remove. Oh, still sticky. I think it was not hardened through. Okay. No problem at all. Oh, this is a problem. Okay. Yeah, it was fresh just a minute ago. Let's apply again. Graciously. press. Maybe a little longer. Yeah, I mean, this is, you don't have to watch it. You can fast forward if you want to. But gluing them into place seems to be a good idea. Yeah, okay. And now comes the soldering operation. So I preformed some hookup wire, and I totally forgot during my layout consideration, I realized that I need a tiny little jumper right here. Let's press that down real good. Yeah, holding in. Oh, yeah. This will probably be one huge big blob, but hey. Okay, it's not that bad, but I forgot that. There are more wires coming here, so no solder here for the moment. Now, for my power blocks. Okay, so one wire goes, and this is live, from here to here, from that bridge, and the other wire goes from here to here. Yeah, I know, I'm a fiddler for detail. Yeah. At least that one looks nice. Yeah. And then we have these two. Yep, that's good too. Okay, now for the ground. sorry, neutral. When you watch closely, you notice that I wired up the wrong connection. I corrected that, and now I have my preformed hookup wires for the rest of it. Just making sure everything is nice and flat. This goes oh, come on. This goes here. Or was it the other way around? Sorry. Yeah, it was the other way around. It's just the distance between the ground and that cable. The ground. Between live and neutral. I don't like that. Better. So, that was our primary side. I guess we have more than enough spacing between live and neutral. Yeah. Now comes the 5-volt side. Sorry, forgot to press record. I have my preformed hookup wires for the DC side. And we're going to solder them in. I guess this one goes here. Yeah. It could be a wee bit shorter. Okay, doesn't look like we have a short. And the last one. And that's it. Just snip off the exact length of the pin. Yeah, they go everywhere. Don't worry. And just to be on the safe side, just applying some more excessive amount of glue around the connectors. Yeah, that was really excessive. And we let that cure for a while. And then we will see if this thing is working, in fact. Of course, after applying copious amounts of glue, no project would be really finished without applying copious amounts of hot snot. Just to be on the safe side, you know. And I really want to keep that leads that are connected to main isolated from touch. Yeah, that has to go. Yeah, looks good. Now put on the isolation, and I noticed I totally ran out of M3 screws. Metric. I'm sorry, but I'm a metric guy. Yeah, you could use plastic screws, but yeah, there's enough distance. Let's see if that fits. Yep, perfectly. I still have some flat ones to hold it there. So, the finished product. 2 times 5 volt, completely isolated, no common ground, no nothing. 0.2 amperes, 200 milliamperes, about 5 by 5 centimeters. So we all want to know if this thing is actually working. So I crimped some wire and we're connecting that to mains. It's okay. This should be 20 volts DC. Wonderful. This should be plus, and this should be minus. I'm not shorting out anything. Yeah, I might. Now that's better. Okay, and now we see if we can connect mains without a big bang. .98 minus. So yeah, sorry, switch the connections. My fault. Okay, let's try the other side. Let's see how long it holds. I mean, there's absolutely no load on it, but this is probably high impedance input, but holds it for quite a while. So maybe if we connect the other side. Oh, see, I shorted it out again. So now we can test if it survives a short, even if not connected to mains. Oh, and it was still connected to mains. 4.98. Ha! Okay. The short circuit protection, it was a feature of these things, obviously works. Wonderful. And now I removed the right cable. And okay. No, still holding its voltage. Anyway, let's see if I can connect that without shorting it out again. Yep. This will go into my bench supply. I got it. Card. if or link below, whatever. Yeah, just another piece of the puzzle. Yeah, thanks for watching. Bye.